Keyshawn here, and I'm going to follow up from the last video all about rotation curves with a new series that I'm calling Behind the Scenes, where I kind of like run it back and answer a question that is probably burning on your mind, which is how exactly do we measure that? So for the rotational curves video, I talked about how we would measure the rotational velocity of a star in a spiral galaxy like Andromeda. And so maybe you're wondering, how do you do that? How do you actually measure how fast and what direction a star is moving? Well, it's actually a really cool story. Really, really cool story. And it starts in a place where you might not expect. Here's an atom. Okay. Maybe you weren't thinking we were going to go chemistry, but stick with me. Okay. So this is kind of the basic building block of stuff in the universe. So this one's a carbon atom, defined as such by the fact that it's got 6 protons in the middle there. So an atom is kind of the smallest unit you can point at and reliably say, okay, that right there is carbon, and it behaves like carbon. And you can make predictions and observations based off of its chemical properties. Once you get smaller than this scale, you can't really do that in the same way. Okay. And so one of those properties that you can make judgments about is how much energy it takes to excite these electrons. So those electrons marked with a minus there, they kind of hang out on the outskirts of the atom there in these particular energy levels, these allowable amounts of energy that are different for every element: hydrogen, carbon, oxygen, nitrogen, different for all the elements. Okay. And the electrons can actually jump between those levels. So if you shine light on them, they can absorb some energy from that light, jump up, get excited, and eventually come back down and release the difference in the form of light. And that light's got a particular energy, which is to say a particular frequency, which is to say a particular wavelength, which is to say a particular color. And that's what we want to focus on. Every element has its own unique fingerprint of colors that it responds to excite its electrons.